The purpose of this video is just to give you a few little hints and helps, and so you can skip to whichever part of this video is helpful for you. On the notes, you are going to these links, and the links are supposed to explain how to do these types of problems, but I will attempt to do that as well. So, number 4, a math teacher gave her class 2 tests. 25% of the class passed both tests, and 42% of the class only passed the first test. It doesn't say only. Passed the first test. What percent of those who passed the first test also passed the second test? So this is basically the probability that they passed the second test given that they passed the first test. And so that's this conditional probability that we're talking about. And so let's just say, let's call event A that they passed the first test. And event B will be that they pass the second test. Now it's possible that they passed both tests. It's possible that they only did one. But what's the probability? What's the probability that they passed the second test given that they passed the first test? And if you remember, up above we were given the formula for that. So the probability of A given B, or in this case, B given A, you're going to find the probability that both B and A are going to happen. So in this case, the probability that they passed both tests divided by the probability that they passed only the first test. Sorry, I got my B's and A's mixed up. So that's what we're going to be doing. So the probability of B given A is the probability that they passed both tests, and that's the 25%, divided by the probability that they passed the first test. And so that is 42%. And so you figure out that decimal, and that comes out to be 0.6. And so there is a 60% chance that if you know the student passed the first test, that they passed the second test. The second question, in the United States, 56% of all children get an allowance, 41% of all children get an allowance, and they do household chores. So we've got two events. We've got the probability that they're given an allowance. We've got the probability, or the event, I guess, that they do the chores. And so we are going to find the probability that a child does household chores if I already know that they get an allowance. So the probability that they do chores given that we know that they have an allowance. So that's going to be the probability of the intersection of B and A divided by the probability that they get an allowance. And so again, we're going to do that same calculation. The probability that they both do allowance and do chores is 41%, and the probability that they get an allowance is 56%. So 41% divided by 56% is 73%. So if you know that the child gets an allowance, there's the 73% chance that they also do chores. And so you see that that's a different condition than if you just say, what's the probability that a kid gets allowance? Number 6, in New England, 84% of the houses have a garage, 65% of the houses have a garage and a backyard. So the two events are having a garage and having a backyard. And so the percent of having a garage is 84%, and 65% of the houses have a garage and a backyard. So a garage and a backyard is 65. So the probability that a house has a backyard given that it has a garage. So that's going to be the probability of B and G divided by the probability of G. See, that goes right there. So the probability of the two together is 0.65. The probability of them just having a garage is 0.84. And so that's the math you do. And you will get 0.77. So 77% chance that if they have a garage, they have a backyard. Okay, the next two questions, possibly, depending on how you understand it, could take a little bit more extensive explanation. So let me try a couple of things. 2 cards are chosen at random from a deck of 52 cards without replacement. That means you take one, you do not put it back. So that's changing how many cards are in the deck overall and what is there. What is the probability of choosing 2 kings? So the probability of choosing 1 king is 4 out of 52 cards. If you take a king out and you put it in your back pocket, and then you go to the deck of cards and you try to pull out another king, the chances are now only 3, because there's only 3 kings left because you took one out. And then there's only 51 cards because you have one in your back pocket. And so you multiply that together. So 4 times 3 is 12, and 52 times 51 is 2652. And if you do the division there, it's going to be about 0.005, and so that's about a 0.5% chance, so less than 1%. Okay, the next thing that I want to talk about here, just because this is a good problem to take the opportunity, is what if I wanted to prove whether or not these 2 events are independent or dependent? You're going to have a couple questions that are going to ask you to do something like that. And so if you remember, in this, I can't make this move. There we go. In this right here, we can tell whether these events are independent if this is true. So we're going to use that idea. So if I'm going to prove is the probability of getting a king is 4 out of 52. The probability of getting a king the second time is a king given that a king already happened. And that's what we did in this problem right there. So I know that that's 0.005. And so just to be clear, what I'm doing is I'm proving whether these 2 events are independent or dependent. So is the event of getting a king independent from getting a king given that a king already was drawn? And so we're going to prove that, and the way that we do that is we're going to say the probability of a king given that a king has happened, and that's from the problem up above, is that approximately equal to the 4 out of 52? And so are those 2 decimals like really close to being the same? And by really close, I mean like within, a 100th or so. I don't know that there's a really hard and fast rule for exactly how close, but you'll know if they're close. If you look at the decimals, they're not even close, and so these are dependent. Okay, the one depends on the other one. If they were approximately equal to, so if they were really close, like if this one's 0.00, oh, whoops, the other one. If this one's 0.005 and this one was like 0.006, I guess, then that's pretty close. That's within 1,000th, and so you could say that they are probably dependent. Okay, the next question, number 8. On a math test, 5 out of 20 students got an A. So 5 out of 20, and we'll say that event A is getting an A. If 3 students are chosen at random without replacements, that means you take a student and then you take another one, you take another one. What is the probability that you get 3 students that got an A? So think about it like this. You've got 3 places to put somebody. The first time you choose a student, there's a 5 out of 20 chance that they got an A on the test. If you go back to get another student, there's only 4 students left who got an A, and there's only 19 students left. And then if you go back for a third one, there's only going to be 3 students left that have an A, and only 18 students left. And so what you're going to do is multiply all 3 of those numbers together. And you can use a calculator and get a decimal here, and you're going to get about 0.009. So less than a 1% chance. That's not very likely that that's going to happen, but it is a possibility. Okay, the next thing I want to do is I want to talk about number 32 on your homework. And so if you take a look at number 32, we've got some information at the beginning. And so it says that Jack's rolled 2 dice. And so we've already listed a sample space for that previously. And that's what's happening. Event A is that both numbers are even, so both even. Event B is that the sum of the numbers is 6. And event C is that there's at least one odd number. So for number 32, I'm going to do that one and talk it through, and then you can come back if you feel like you need more help with 33, but try to do that on your own. So on number 32, the probability that they're both even, there's on the first die, there's a 1/2 chance that the first one is even. There's a 1/2 chance that the second one is even. And so if you multiply it together, the chance that they're both even is 1/4. So that's event A. Event B, that the sum is 6, if you look back at the sample spaces, we've done the sample spaces before where you have all the die, there are 5 of the 36 that the sum is 6. So that's like a 2 and a 4 or a 4 and a 2. And then if you look at, we don't need C for this particular example. So in 32, it says, are events A and B independent or dependent, and show why. So the probability of A and B, we're going to find that. And so the probability of A and B is 2 out of 36. And that's because of these 5, there's only 2 of them that they're both even, and that's a 2 and a 4 and a 4 and a 2. Those are the only ones that they're both even and they have a sum of 6. All the other ones have an odd number. So 2 out of 36 is the probability of A and B. That's equal to 1/18, and it's approximately equal to 0.055. So using the definitions that we have of independent and dependent, and I'm talking about these right here, using that definition, let's take the probabilities as they're listed in that definition. So the probability of A is 1/4. The probability of B is 5 over 36. And so the probability of A and B, if they were independent, would be 1/4 times 5 over 36. And so that would be about 0.0347, and then the 2's repeat. And so if you look at the probability of A and then the probability of A and B, they're not close to being together or the same. And so we're going to say that they're not equal. And so because of that, these are dependent, and that's how we can tell. The last one I'm going to show you here is help on homework number 33. You should only be doing this if you've already tried number 33 and you are either just checking to see if you did it right or getting an explanation why, because you don't understand how I got the answer that I got when you check the answer key. So number 33, we're still using the same events where Jack's rolled the 2 dice. This time we're talking about events B, which the sum is 6, and event C, and that is where at least one is odd. So we've already said that the sum is 6. That's an event or a probability of 5 out of 36. Looking at the sample space, what is the probability that we have at least one odd? And so if you look at the sample space and count them up, there's 27 out of the 36 where at least one is odd. And so again, using these definitions for independent, dependent, we can say the probability of B and C happening, if that's equal to the probability of B times the probability of C, then we could say that they're independent. So we can find the probability of B and C, again, by looking at that sample space of all the 36 ways you can roll a dice. And if you look at the ones where at least one of them is odd, how many of them have a sum of 6? And so if you look at that, it's going to be 3 out of the 36. FYI, that's 1, 5, 3, 3, and 5, 1. And those are the only ones that have a sum of 6 where at least one of them is odd. And that is about 0.083. If we look at the probability of B times the probability of C, that's going to be 5/36 times 27/36. And if you put that in your calculator, you're getting about 0.104. And those are not very close. So they're more than 100th. And so we would say that these events are dependent